Hi, for my project, I looked at the problem in higher education, identifying students at risk of failing or dropping out. Today, this is done reactively. Faculty and mentors usually only notice a struggling student after mid term exams when it's often too late to help. This is strong ML opportunity for three reasons. It's a genuine prediction problem, not a judgment call. The data, attendance, submissions, quiz, sources, LMS logins already exist digitally. And even a small improvement in how early we catch at-risk students translates into real actionable interventions. The CRISP DM business understanding. The business objective here is to reduce fail and dropout rates by giving mentors early warning. My ML goal is classification model that predicts weekly the probability a student fails or drops out. Early semester behavioral signals, attendance trends, submission timings, score trajectory, and LMS engagement. For outcome metrics, I track the actual reduction in fail and dropout rates and how much earlier interventions can actually help in this. For output metrics, I focus on the model level, recall, and AUC since missing at an at-risk students is more costly than a false alarm. To validate this, I'll start with the mentor interviews to see if they trust and act on a risk score. Then I'd run a manual heuristic based pilot in one or two sections, no ML yet, just to see if mentors actually use flags to intervene. If that works, I'd backtest the real model on historic data before running a live pilot comparing an intervention group against the control group. For system design, I'd used a batch prediction recalculating the risk scores weekly rather than in real time. Since mentors review the flags on the cadence, I'd host in the cloud since it needs centralized access to LMS and student data. And I'd refrain the model each semester rather than keeping it static since student behavior and course conditions change over time. These are some of the risks in production. Key risks include training serving skew if live data has gap, faculty don't consistently log, consist drift if grading or teaching modes change, and alert fatigue if the precision is too low. Mentors may start ignoring flags altogether, which is as much an adoption risk as a modeling one.